Now, in this particular question, we are told that in the diagram above, join QR. So we are meant to join, we are told to join Q and R together. That's the first instruction. So, and show that angle RPS so obviously R and P are not joined. So if you are looking for angle RPS, R and P must join together, so we have to join it. RPS, this angle. We have to show that this angle RPS, this angle here, equals to angle QRT, this angle here, angle QRT, this angle. We have to show that these two angles are equal. If you have to label this angle as, let's say, A, and this angle as B, this angle A is our RPS. Let angle RPS be A, and angle, what second angle? QRT. QRT, that is QRT, be B. We have to show that A equals to B. If we can do this, we are done with the first part. Now, if you observe, first, this SR is a chord, so this is a segment. So this segment produces angle A. This segment also produces same angle here. So definitely, this angle and this angle SQR. Angle SQR must also be equal to what? Angle RPS, which is A. So meaning this angle here also must be A. The question is why? Because they are angles in alternate segments. Same segment. Angles in the same segment are equal. Note our aim is to show that A equals to B. Now when we check here, this line are SQ and RT. SQ, RT are parallel. Then we have this QR cutting them. So definitely, since these two lines are parallel, this two angle must be equal because they are what? Alternate angles. Alternate angles are equal. The next is to show that these two angles are equal. So this angle here is SQR. Angle SQR must be equal to this angle here, QRT. Angle QRT. Why? Because they are alternate angles. And alternate angles are equal. So what's SQR? SQR is A. What's QRT? QRT is B. A equals to B. We've shown it already. Quite easily done. No quad erat demonstration. Now for the second part, we have to show that PRS, this angle here, equals to angle QTR. Where is QTR? QTR, this angle. We have to show that this angle equals to this angle. So let's make PRS to be, let's say, X. QTR to be Y. Let's PRS be X and QTR be Y. We have to show that X equals to Y. Now, if we notice, this PS, this segment forms this angle X, angle PRS, and this same PS forms this angle here. So these two angles are the same. So if this angle here is, so let's call it A, which is angle PQS. Angle PQS must be equal to angle, this angle here, which is PRS. What's PQS? We label it as A. PRS as what? X. What's the reason for this? Same reason here. Angle in the same segment are equal. Then if you observe QS, TR, they are parallel. We have parallel lines. Then we have this horizontal line cutting them. So obviously this angle and this angle are the same because they are corresponding. Meaning Y and A are equal. This Y is actually our QTR. Angle QTR must be equal to this A, which is what? SQP or QPS. Angle PQS. PQS, this angle. Why are they the same? Because those angles are what? They are corresponding angles. Corresponding angles. What do you call QTR there? QTR is what? Y. What's PQS? A. Now, from here, Y is A. X also A. If X A and Y is A, it means Y and X are equal, which is what we are meant to show here. This our Y is actually our angle QTR, and our X is actually our angle what? PRS, which is what we are told to show. Now, in this question, question 2, from 2004, number 13, objective. We are told to find angle QRS. QRS, this angle here. Let's call it X. Let angle QRS be X. Now, given that POQ is a diameter. Whenever you have a diameter in circle theorem, go and check theorem 4. Angle in the same circle is 90 degrees. So, this is the diameter, and we are given this angle here. So, tracing this here, I can join P and S together. And according to the theorem, if I have a circle this way and I have a diameter, this angle is surely what? 90 degrees. So this angle here is what? 90 degrees. So if this angle is 35, you can actually get this angle here using some angle of the triangle. Let's call this angle Y. That's angle SPQ. Let's call angle SPQ Y. So let's angle SPQ be Y. From here, obviously, if we add this angle 90 Y and 35, 90 degrees plus Y plus 35, we must get what? 180. Y. Sum of angles in the triangle. From here, Y plus 125 equals to. So what is Y? 180 minus 125. So the value of Y is what? Then, but our aim is to get X. Now we check. 1, 2, 3, 4. Look at this circle. We have 1, 2, 3, 4. This is a cyclic quadrilateral. So since it is a cyclic quadrilateral, this angle plus this must give what? 180. Because the sum of opposite interior angle of a cyclic quadrilateral is supplementary. So it means X plus Y must give us what? 180. X plus what is Y? 55. Must give what? So what is X from here? 180 degrees minus 55. So X goes to 125 degrees. So therefore, angle QRS we are looking for is 125 degrees. So here we apply two theorems, or even three. On that second theorem we apply two. Angle in the same circle, opposite angle beside collateral, then the general one, sum of angle in the triangle. Now in this particular question, still on 2004, number 27, we have to look for the value of QRS. QRS, we are looking for this angle here. So, first, anytime you see a tangent, the last theorem should come to your mind. Angle in alternate segments are equal. Meaning, this angle, the angle between this segment and this tangent must be equal to what? The angle in the alternate segment must be equal to this. So meaning, angle QRS, which is what we are looking for, must be equal to angle RPQ. This RPQ. Secondly, our aim is to get QRS. So if QRS is A, this also be A. Angle in alternate segments are equal. That's the reason for that. Then, if you look again, this arc RQ subtend this AT at the center. This same RQ subtend angle A at the circumference. Theorem 2. Angle subtended by an arc at the center of a circle is twice the one subtended at the circumference. So obviously it means angle, this AT, that's ROQ is twice angle, this one here, that's RPQ. So I think I didn't label this very well. I wrote PQR, PRQ. PR instead of it ought to be RPQ. This is RPQ. Meaning this angle 80 is twice this. What is angle ROQ itself from the question given to the 80? Twice. What's my angle RPQ? A, which is as what? Angle QRS. I'll replace RPQ with QRS because they are the same. And our aim is to get RQS. So if you divide by 2 from here, obviously we are going to get our QRS to be 40 degrees. 8/2, 40 degrees. Very simple. For this question 4, 2004 OBJ 30, we are told to find QPR. QPR, this angle. Let's call it X. Let's angle QPR be X. Now, if you observe, QR, RS and OS rather, QR, OS are parallel. That's why these arrows are put there. So obviously, this angle and this angle are the same because they are what? Alternate angles. So you can say angle, this angle QRO, angle QRO equals to angle ROS, which is equals to 35 degrees. So meaning QOR rather is 35. So we can just put it here as what? 35 degrees. Now if you observe, center circumference, it means OQ, OR, they are equal because they are both radius, that's radii. So this triangle becomes an isosceles triangle. And for an isosceles triangle, the base angles are equal. So it means this angle OQR, angle OQR is equal to angle what? QOR, because they are what? Base angle, just write isosceles triangle. So from here it means OQR is also, so I can write 35 here. Why am I doing all this? Our aim is to get X. Well, I know obviously that QR subtend this angle, this particular angle at the center. And this same QR subtend this angle at the circumference. Angle at the center is twice this angle. So first, let's get this angle first. Which can get this of angle triangle. That's angle QOR. Let's angle QOR be Y. So let's call this one Y. So it means Y plus 35, that's 70. Must give us what? 180. Obviously Y equals to 110. And from here, angle at the center Y is twice that at the circumference 2x. So what is Y? 110 equals to 2x. Obviously from here x equals to 110 over 2. Obviously x equals to, so the angle we are looking for, angle QPR is 55 degrees. The next question here, same year, 2004. In 2004, we have 5 questions on South theorem with OBJ only. So find the value of x. Where is x? We have 3x here. Now looking at this is actually a cyclic quadrilateral, so no panic. Now look at this. Outside here we have a small triangle WRM, and there's one stripe here, another stripe here. These two stripes indicate that this triangle is isosceles triangle, meaning this angle here and this angle here, they are equal. I think this is the simplest ever. Why? If you apply, is it theorem 5? Exterior angle of a cyclic quadrilateral equals to what? Opposite interior. And what's the opposite interior? This angle. It's not 3x. The one opposite, this is. So this angle here and this angle here, they are the same. Or we can also say this one here and this one here, they are also what? The same. So if you are checking this equals this, if it's this equals this. But because these two stripes, because these two angles are equal, any of the two works. So in this case, you are going to take this and this. So this angle is WRM. Angle WRM equals to angle QPM. QPM, which is 3x. Now see these two angles are equal. It means angle WRM equals to angle, what was here? RWM. RWM, meaning this. So if this and they are both 3x. So it means if this angle here is 3x, this is also what? 3x. Sum of angle in a triangle 3x plus 3x plus 30 must give what? 180. 3x plus 3x? 6x. 180 minus 30? 150. So obviously x equals to 150 degrees over 6. So x equals to 25 degrees. Now for this question 6, 2004, number 39, still OBJ. When you look at this, some people think this is actually a cyclic quadrilateral, but it is not a cyclic quadrilateral. Why? Because this O is not touching what? Any part of the circumference. This is actually theorem 2. Angle at the center, twice one of the circumference. But this time around, we are considering the what? Major arc, PR. Meaning this angle here is twice this angle. This angle is twice this angle. So meaning reflex POR equals to twice angle PQR. But do you know POR? No. Let's call POR, let's call it X. If we add X, which is POR, plus 68, we must get 360. Why? Sum of angle at a point. Angle at a point. So from here, obviously, our x equals to 292 degrees. Then this angle x, which is POR, is twice. So applying this principle, POR, which is x, is 292. So 292 equals to twice PQR. What's PQR? 2x plus 15. And we have to total for x. So delta by 2. This 146 equals to 2x plus 15. So we remove 15 from 146, divide the answer by 2, we get x to be 65.5 degrees. So in this question, theory number 7b, 2004. In the diagram, PR is a chord of the circle center O and radius 30 centimeters. Angle POR, this angle here is 180 degrees. Calculate to 3SF. 1, the length of the chord. The length of the chord of a circle is 2R sine theta over 2. Very direct. So that's 2. What is R? 30. Sine 120 over 2. So that's 60. Sine 60. And the final answer is 51.96. So to 3 SF, that should be 52. The second point, the length of the arc PQR. The length of an arc of a circle is theta over 360 times 2 pi r. So from here, the length of the arc equals to 120 divided by what? Times 2 times 22 by 7 times 30. So from there, the length of the arc becomes 62.9 centimeters. Then the third part, the perimeter of the shaded portion. This shaded portion is called what? A segment. So perimeter of a segment is the length of the chord plus length of the arc. Length of chord plus length of arc. And from here, the perimeter of the segment becomes, for the chord, 2.0, 62.9. From there, the perimeter of the segment becomes 94.9 centimeters. So this question is actually a bonus. In this particular question, same here, theory 8a, find the area of the minor segment. So here we have segments, this one above and this one below. So we are looking for the area of the segment below. And recall, we already said area of a segment equals to area of a sector of the circle minus area of the triangle. So the whole of OXY is a sector. And area of a sector is theta over 360 times pi r squared. Minus area of a triangle is half r squared sine theta. So done. The angle is 96 degrees over 360 times 22 over 7 times 5 squared. That's sector. Minus half 5 squared sine 86. From here, the final answer becomes subtract in this question. To get the area shaded, we can do that easily by removing this major sector. This unshaded part is the major sector from the square. So we can say the area shaded equals to the area of the square. Let me see more. Area of the square minus the area of the sector. What's area of a square? Length squared, meaning this length from here to here, all squared, since all the lengths are equal. But are we given the length? No, so you have to look for it. What's area of a sector? Theta over 360 times pi r squared. Are we given r? Yes. So are we given theta? We are partially given, because since we are considering the major sector, we are not using this angle, we are using what? This angle. If total angle in a circle is 360, and this one is, sorry, at the point is 360, and this one is 80, the remaining one is going to be what? 2. So it means our theta is actually 280. So we don't have issue with the sector again. You know the theta 280, the radius 7. We only need to get the length of. This is where Sable's theorem enters. Now look at this. This length of this circle is actually a tangent to this circle. This is actually a tangent to this circle, and this is the point of contact. Any line drawn from the center of a circle to touch a tangent at the point of contact is perpendicular to it. I can also draw from here to this point of contact also. It's also what? 90 degrees. Not only that is 90 degrees. This one and this one are both equal. Why are they equal? Because center circumference radius. Center circumference radius. It means from here to here is also 7. So from here to here is also 7. Definitely, since this is 90, 90, this is actually a square too. So it means from here to here is also 7. So this is 7. If you apply same thing here, this will also be 7. From here to here is also 7. From here to here will also be 7. So it means the length of the square is actually what? 7 plus 7, 14 centimeters. We are done. So the area shaded now becomes back here, 14 squared, area of the square, minus theta 280 over 360 times pi, then r 7 squared. So from here we can easily get the area shaded. Subtract. Now in this particular question, still in 2004 theory 12b, PQ right here is Z, OK is Y, and angle OKP is 90. Find the value of Z in terms of X and Y. So we are told that from here to here is Z. From this portion to this portion is Z. So we are using theorem 1 here. Any line drawn from the center of a circle to bisect a chord, this chord QP, is perpendicular to it. A line that bisects a chord must be perpendicular to it, meaning any perpendicular line from the center of a circle will bisect a chord. So if from here to here is Z, it means from here to here will be half of Z. So that is half of Z, or Z over 2. So we can bring out this right angle triangle here. This is 90, this is Y, this is X, this is Z over 2. And from here we can now apply Pythagoras theorem, which says that the square of the hypotenuse equals the sum of the squares of the other two sides. So we have x squared plus, equals to y squared plus z squared over 4. We can multiply 2 by 4. This becomes 4x squared equals to 4y squared plus z squared. From here, bring this here. It means 4x squared minus 4y squared equals to z squared. And from here, it means z squared equals to 4x squared minus 4y squared. So z squared equals to this same thing as writing 4 into brackets. So this is y squared. S squared minus y squared. So when we look for the square root of both sides, that's root 4 into s squared minus s squared. Z becomes 2 roots s squared minus y squared. Or we can factorize as x minus y, x plus y, difference of 2 squared. The last question for this segment is from 2004 theory 12c. So we are told to find angle QPS. QPS, the goal of this. And angle RQS. RQS, the whole of this. Let this RQS be B, and let the whole of this be A. To get the value of this A is easy. Why? Because in this triangle PSQ, from triangle PSQ, we are looking for this angle. We already have this full angle. So if we know this, we are done. If we know this angle here, we are done. And we can actually get this angle here. Why? Because this angle at the center by arc PQ, and this angle at the circumference. So this angle here is twice what we have here. So this angle here is PSQ. So angle, the one at the center, POQ, is twice angle PSQ. Since POQ is 160, then PSQ definitely is going to be 80 degrees. Then from there, using some angle in the triangle PSQ, it means this angle, what it wants to be 80. This angle PSQ, which is 80, plus A, which you are looking for, which is angle QPS. This one here, angle QPS, plus this 40 given in the question, that's PQS, must give 180 degree. This is 80, the one we are looking for, and this is 40, equals to 180. So QPS equals to 60 degrees. Why? 80 plus 40, 120. From 180, 60. That's the first part. For the second part, we want to get the value of this B. This actually easy too. Why? Because PSRQ is a cyclic quadrilateral. The sum of opposite interior angle of a cyclic quad, meaning the whole of this angle and the whole of this must be equal. So therefore you can get B. We've already let RQS will be here. So from here, this angle, which is 80 plus 45 degrees, plus this whole angle, which is 40 degrees plus B, must give 180. Why? Sum of opposite exterior angle of interior angle of a cyclic quadrilateral is supplementary. So from here, 80 plus 40 is 120. This is B. So 120 plus 45 is 165. So B equals to 180 minus 165. B equals to 25. 15. So we've come to the end of this session. Now in this question, we have this circle and we are told that angle ACB, where is A? ACB, this angle, is given to me 37 degrees. Angle ATB, where is ATB? ATB, this angle here is given to me what? 42 degrees. So we are told to find angle ABT. ABT, this whole angle here, let's call it X. Let ABT be X. And angle AEB, where is AEB? AEB, this angle, let's call it what? Y. So we are looking for what? So we have to analyze the diagram first before you can what? Solve. When you observe, you notice that we have a triangle on this line TC and line AD. This shows that this line TC and AD, they are parallel. Anytime you see parallel lines in mathematics, look for a line that cut them together, that cut the two lines. Then from here, you most likely see an alternate angle. And these two angles are equal. So first, let's try to look for the alternate angle. Look at this. Try to form like a Z shape. So if you go this way, when we come here, and we go back here, we see that this angle has to be what? 37 also. Without being told, we have to know that those two angles are equal because they are what? Alternate to each other. If you notice, this TA is a tangent and this is the point of contact. And from here, we have this chord. Definitely, this is a segment. So this angle here must be equal to the angle in the alternate segment, which is 37. So if this angle here is 37, the angle is also what? Then obviously, using some angle of the triangle, we can get the value of X here. So let's do 42 degrees plus what? 37 degrees plus X must give us what? 190. What is 42 plus 37? 79 plus X equals to? So from here, it means X equals to 180 degrees minus 79 degrees. So what is the value of X class? 1. Is that understood? The next is for us to get the value of Y. Now, to get this Y belongs to this triangle. But before that, when you check this AB, it is a chord, and this is the segment. So this segment forms this angle 37. This same segment forms this angle D. So it means if this angle is 37, this angle here is also what? 37. Why? They are angle the same segment. Then when you observe, this angle Y is like exterior angle to triangle AED. Let's draw it out. This Y, this is a straight line. So this is 37 degrees. This is also what? You have to know that exterior angle of a triangle equals to the sum of the opposite what? Interior. So Y equals to 37 degrees plus 37 degrees. And from here, what's Y? What's Y? So we've gotten ABT and AEB. In this question, ABC are 3 points on a circle. The tangent at C meets AB produced at T. If ACT is this, ATC is this, calculate the angles of triangle ABC. So let's sketch the diagram before you can get the better view of the question. Say this is a circle. We have point ABC. A, just pick any 3 points, B, C. So ABC. Let us join the 3 points. This, and this. Tangent at C, meaning we have a tangent, a line that touches C. So tangent at C meets AB, produced at T. So it meets AB, produced at T. So this is tangent at C. It meets AB, produced at T. So if we produce AB here, the line will never meet. So let's suppose AB is produced this way. So this tangent is produced this way. So they met at T. So this is our T. Let's move on. If ACT, the whole of this angle is 103 degrees, and ATC, you can say ATASA. ATC is what? 43 degrees. Calculate the angles of the triangle ABC. It means we want to get the value of this angle, let's call it X. The value of this angle, let's call it Y. And the value of this angle here, let's call it what? Z. So our aim is to get X, Y, Z. Now, anytime you have a tangent, go and look for angle in alternate what? Segments. So let's find it out. Now, for this tangent here, let's take this chord. So this is a segment. So this angle here must be equal to angle in alternate segment, which is what? This X. So it means if this angle here is X, this angle here must also be what? X. Must also be X. And we are told that the whole of this angle is 103. So it means X plus Z equals to 103. Equation 1. Then when you check for triangle BTC, this TB is produced. So this Y is exterior angle. Exterior angle of a triangle equals to the sum of the opposite interior. So it means Y equals to what? 43 plus X. Equation 2. Then lastly, for this triangle, sum of angle in a triangle gives what? So we have X plus Y plus Z equals to equation 3. Here we have 3 unknowns, 3 equations. So meaning we can solve simultaneously to get our correct answer. Now in equation 1, we already have X and Z. In equation 2, we have X and Y. So we can replace this Y with X and Z from here. So from equation 3, we can say Y equals to 180 degrees minus what? X plus Y. This is equation 4. Let's now come back to equation 2. Let's place the Y in equation 2 with what? This. So from equation 2, instead of writing Y equals to 43 plus X, we can just write what? 180 degrees minus what? X plus Y equals to 43 plus X. Let's write this. So this 180 minus X minus Y equals to 43 plus X. Right? Sorry, this should be Z. This should be Z. Z. This should be Z. This should be Z. So from here, it means let's bring everything here. X, this minus X, when it comes, it becomes plus X. X plus X is what? 2X. This minus Z crosses and become what? Plus Z. Right? Equals to, let's bring the 43 here. 180 minus 43 is what? Then let's go to equation 5. Then let's go back to equation 1. Equation 1 is what? X plus Z equals to equation 1. Now let's subtract. From here it means X equals to, subtract. X is 34. From equation 2 we can get Y, because from equation 2 Y is what? 43 plus X. So therefore Y equals to 43 plus what is X? So from here Y is what? 20, 77. That is y. Is that y? So we cannot get z. From equation 1, we can get z because from 1, x plus z equals to? What is x? X is what?
34.
Then from here, it means z equals to 103 minus 34. So therefore, what is z? 60. So that is the answer. We've gotten x, y, and z. This solution could have been shorter and would have saved the stress of doing simultaneous equation if we had considered this whole angle. Since this whole angle is given as 103 originally, we are looking for x, and this angle is given. So consider triangle ATC. So using some angle in a triangle, 43 plus 103 plus x, we'll get x with 34 directly. And after getting the x, it's very easy for us to get z. Why? Because this x here, this is a tangent, this is a chord. This x equals to what? This x. So the x 34, so this is 34. 34 plus z must give us 103. Then we get z directly. After that, you can get y using some angle in a triangle. X, which is 34, plus z, which is what? 69, plus y equals 180. Then you get y. That will be a lot shorter. We have this y question from 2017, question 19. We are given two angles. We are given angle TSR or RST to be 46 and angle RTS to be 29. We are looking for angle STO. STO. This small angle, we are looking for it. So this is very simple, unless you are not that observant. When you look at this, this is an arc. This arc subtends this angle at the center, and this same arc RT subtends this angle at the circumference. So angle at the center is twice the angle at the circumference. So it means the angle here is twice of this. What is 2 times 46? So it means the whole of this angle is actually what? 92. So let's look at this triangle. This angle here is 92 degrees. Now if you observe, this is the center of the circle. Then RO is radius. TO is also radius. So this triangle ROT is an isosceles triangle. So therefore this angle and the whole of this angle should be equal. So let's call this angle x. This will also be x. So if we do 92 plus 2x, we get what? From here, 2x equals to what? What is 180 minus 92? So from here, x equals to 44 degrees. Now it means the whole of this angle here, the angle we are looking for STO, let STO be y. So it means this angle here is y. So if we add y and 29, y plus 29 gives the whole of this angle, which we've got to be x. And what is x? What is x? From here, y equals to 44 degrees minus what? So what is the value of y from here? 18, 15 degrees. So that's the final answer, 15 degrees. Now, look at this question. This is x. In this circle, in this diagram, we are told to look for WYZ. WYZ, this angle. Let's call it angle. There's already x here. Let's call it y. First, this y we are looking for appears in triangle YWZ or ZYW. Now, first, let's check this. When you observe everything here, this stripe and this stripe, YZ and VZ are equal. Meaning this triangle ZVY is isosceles. So if this angle here is 52 degrees, then the whole of this angle also must be what? The whole of this must be 52. Then we can get this angle. So we don't know what we're going to use it for, but let's get this angle. Let's get the value of this angle. Let's call it A. So obviously, 52 degrees, which is angle V, plus 52 degrees, which is angle Y, the whole of this, plus A must give what? So here we have 104 plus A equals to From here, what is value of A directly? So we are not taught to get A, but we may need it. Next, look at this. XVZ is a triangle. XVZ is a triangle. And XV is produced. Definitely this 52 is an exterior angle. Exterior angle of a triangle equals sum of its opposite interior. So meaning, for example, look at this. This angle must be equal to this plus this. So this 52 must be equal to 20 plus what we have here. We don't know what is here, let's call it B. Obviously, 20 plus B must be 52. So 52 degrees equals to what? 20 degrees plus B. From here, B equals to 52 minus 20. And that is what? B is what? So, we know the whole of this. Now, we know this. Now, but our aim is to get Y, which is this. Now, this Y belongs to triangle WYZ. And in this WYZ, we already know the whole of this angle. You know A and B, that is 76 plus 32. This angle is known. If we can get the value of this angle, we are done. We just use some angle in a triangle, which we can get. How? Look at this. YZ is a chord. This YZ produces 52. This YZ produces the angle that is here. So definitely 52 and this angle they are what? In the same segment. So if the angle is 52, this angle here must also be what? Recall, angle in the same segment are equal. Look at this. So this segment produces this angle. This here produces this angle also. This and this must be equal. We reach 52. Then from here we can use sum of angle in a triangle. So in triangle WYZ, this angle 52 plus what we are looking for, Y, plus the whole of this, A plus B, must be what? 180. So what is the value of Y? That's what we are looking for. What is A? 76. What is B? 32. Equals to what? 180. So Y plus 52 plus 76 for 32 will give us what? 160. Equals to what? So what is Y from here? 180 degrees minus what? So Y equals to, what is our angle? WYZ 20 quad erat demonstrandum. Now we have this question from WASSCE 2016 theory 3A. We are told to get the value of angle VUS. VUS, this angle labeled X. Now when you observe, this is a cyclic quadrilateral. We can get the value of X if we know the whole of this angle. This plus this gives 180. Question is, how can we get this whole angle? This is a straight line. This angle plus this third angle must give 180. Angle on a straight line. So if I know this angle, I know this. If I know this, we can get this. Question is, how can we get this angle? Now, this is a tangent. Yes or yes? Yes. So for a tangent, from here we have this chord. So let's look for the angle in alternate segment. So the angle here must be equal to angle sub 10 at what? But if you notice, this point connects to V, but this S didn't connect. So we can connect it ourselves. So definitely this angle here, if this angle here is A, this angle here must also be what? A. Angle in alternate segments are equal. Now, how can we get A? Look at this. RS is a chord. This RS subtend V at the circumference. At the other what? This RS also subtend what? This 28. So definitely A and 28, they are what? Angle in the same segment. So from here it means angle A equals to 28 degrees. Why? Angle in the same segment are equal. We've applied two rules already. Alternate segments, same segments. Now from here we can get this angle. Let's label this angle as B. Definitely 46 degrees plus B plus A must give me what, class? Must give me what? Now equals to what? What's the value of A? A is what? Equals to, now 46 plus 28 gives what? 70 plus 18 equals to what? From here, what is value of B? 1. Now, B and X. If we add B and X, we must get what? Sum of what? Opposite angle of a cyclic So what is the value of b? Plus x equals to. So what will be the value of s, class? So s equals to 70. Which means angle VUS is 74 degrees. Without this extra construction, we can still get the value of what? X directly. Why? Because here, this RS is a chord to this tangent. So this angle will be equal to this directly. Without even doing this, this and this are equal directly. So this is 28. So if you use angle on a straight line, you can get B straight. I get B, you get X. More direct. You are told to look for what? We want to get the value of W, X, and Y, Z. So first, when you look at this shape, this is a right angle triangle, right? So therefore, total angle in a triangle is what? 180 degrees. 21 degrees plus what? Plus 90 equals to. So from here, all of W. Now, the one we can get easily next should be the value of X. Why? When you check from this point to this point, this is an arc. This particular arc subtend this angle at the center, X. This same arc subtend this W at the circumference. So angle at the center, which is X, is twice that at the circumference, W. From here, it means our X equals to 2 times 69. So what value of X from there? 138. The next you can get is the value of Y, because total angle at the point is 90 is what? 360 degrees. So if I do X plus Y, we must get what? So what is the value of X? Plus Y equals to. So what value of Y from here? So what is Y? Y equals to 222. So we've gotten XY. So we cannot get the value of Z. Why? Because this remaining arc from here to here, this arc, subtend this Y at the center. And this same arc, subtend this Z at the circumference. So center, circumference. So it means angle at the center of Y is twice that at the circumference, Z. So what is the value of Y? 222 equals to 2Z. From here, what's the value of Z? So therefore, Z equals to what? Now, to question 2 now. We have to get G, H, F, E. Now, from here, obviously, total angle on a straight line is what? 180 degrees. So E and 134, they are adjacent angles. So E plus 134 degrees must give us what? So directly, what will be E? 180 minus what? So what's the value of E, class? So it means E equals to 46 degrees. What can we get next? Yes, we can get F next. Why? Because this angle at the center is twice one at the circumference. So it means F equals to what? 2E. So what is E? 46. So from here, what is F? 90. Now, if you observe, this is the center, circumference. So this is radius. So this triangle is the what? It's an isosceles triangle. So it means the value of G and H are equal. G and H are equal. So we can say F plus G plus, instead of H, I can write G again. Must give us what? 180 degree. What is F? 92 degree. G plus Z, 2G equals to what? From here, it means 2G equals to 180 degree minus what? What is 2G, class? Miogba. So 2G is what? 88. From here, divided by 2, what's G? So since G and H are equal, what's H also? So to this question, this is a triangle. And two angles are already given. Sum of angle in a triangle is what? So T plus 81 plus 53 must give us what? So what is T? 180 degree minus, what's the addition of this one? 130. 134. So what's the difference? So it means T equals to 46 What can we get next? The next we can get is U, because this is a cyclic quadrilateral. So sum of opposite interior angle of a cyclic chord, in this case T plus U, out or is supplementary. So what's T 46 plus U is 180. So what is 180 minus 46? So that's the value of U. Now back to this diagram. These two stripes shows that these sides are equal. So definitely this angle V and W must be equal. So since V equals to W, so we can, after adding all this angle, it means this U here, U plus V plus W, we can write plus V again, must give us what? So what's the value of U got in? 134. So 134 plus 2V equals to, so 180 minus 134, 46 degrees. So do I start by 2? So if V is 23, what's W? So we've gotten all the letters. Is that gotten? For the fourth question here, in this diagram, obviously these two angles are equal because they are vertically opposite. Anytime you have two lines cross each other, this angle here and this must be what? Equal. Obviously, A equals to 43 degrees. When you check, this is radius, this is radius. So definitely A and C must be equal. A equals to C. So definitely, since A is 43, what is C? So coming to this triangle, A plus B plus C must give us what? What is A? What is C? Equals to 43 plus 43 will give us what? Equals to, what is B straight? So B is what? We've gotten the value of ABC, right? Now we can get D directly. Why? Because this B is angle at the center of this chord, right? And this D is the angle at the circumference. So B equals to what? 2D. What is B? So that was by 2. What is the value of D? Miogba. So what's the answer? Now for this next question, we are to look for this unknown angle. Let's label it as angle X. Obviously, this shape is a cyclic what? Quadrilateral. Then we can actually get this angle here. This angle and this angle, they are opposite angle of a cyclic quadrilateral. If we add this and this, we must get what? Let's call this angle Y. So it means Y plus 62 must give us what? So what is Y straight? What is the value? 1, 1. To get the value of X here, we need to know these two angles so that we can use sum of angle in a triangle, right? So if this angle is 85 and every angle, total angle here is 180, this angle alone is going to be, the value of Y is already 118. What will be this value here? 62. So using sum of angle in a triangle, so if we add 62, 95 and X, we must get what? 180. So from here, 60 plus 95 will give us what? Plus X equals to? So what's the value of X from here? 20. Another way of solving this question is to apply one of the theorem related to cyclic quadrilateral. Exterior angle of a cyclic quadrilateral equals to the opposite interior. This angle and this angle are the same. Exterior angle equals to opposite interior. So if this angle is 62, this angle is also what? Then this is what we are looking for. Let's call it X. Another law, theorem. Exterior angle of a triangle equals to the opposite, equals to sum of the opposite interior. So 85 degrees equals to 62 plus X. So X directly is 85 minus 62. So the value of X is what? Now to solve this question, this particular one, we might need to do extra construction. Let's join this point to this point. This is radius, obviously. So these two angles must be equal. So total angle in a triangle is 180. From 180, if you remove 116, what will be left? So when you remove 116 from 180, you get 64. So let's split it into 2. 32 degrees. 32 degrees. This is the angle we are looking for. Let's call it x. Recall, angle at the center is twice the angle here. So I mean this angle is times 2 of what we have here. So when we divide this angle by 2, we get this. 116 divided by 2 gives what? Now we can now apply some angle in a triangle. For this whole triangle, this is 58. We'll take this one together. So let's add 58 degrees plus these two together is what? 25 and 32. Right? Then this one, x with 32 gives what? So 25 plus 32, x plus 32 equals to, so what's the sum of 58, 57 and 32? So that will be 147 degrees plus x equals to, so to get x we subtract 147 from what? So what is x? 30. For x number 7, we are going to apply theorem 2. Angle at the center, this one, is twice one of the circumference. And this one we are looking for x. So if this one is x, this angle here is actually 2x. Because the angle here is twice the angle here. So total angle at a point is what? 360 degrees. So if you do 2x plus 126 degrees, we must get what? So it means 2x equals to 360 minus. And that is what? So what will be x? So the value of x is what? Now, for this particular question, in this question, this line is actually a diameter. Whenever you have a diameter, look for 90 degrees. So from this point, trace it here. And the second point here, trace it here. So definitely this angle is what? Angle in a semicircle is one right angle. Is that clear? When you observe further, we can see that this arc or this particular chord or segment subtend this angle here, given as 20. So this angle here must also be 20 degrees. Angle in the same segment are equal. The angle we are looking for is actually this. Let's call it x. Now when we now check this triangle, this particular triangle from here like this, down here, up here. All this angle, we have 90 and 20, which makes it what? 100 and what? This one is what? 28. And the whole of this angle is what? X plus 20. So when you add all the angles in the triangle, you must get what? So it means x plus 20 plus 110 plus 28 must give what? So 20 plus 110 plus 28 is what? So that is 158. So x plus 158 degrees equals to what? So what is the value of x from here? 180 minus 158. So what is x? 20. Let me re-explain number 8. In this number 8, we have this line. This is the center of the circle. Then we have this. And we have this. This angle here is given to be 28 degrees. Then this line was joined to this. And this joined to this. This angle is given to be 20 degrees. And we are looking for this x. So first thing we have to realize is this line from this point to this point here is a diameter. So definitely when we trace this here and we trace this here, this angle should be 90 degrees. Angle in a semicircle is 90 degrees. Next, if this angle here is 20, this angle here too is 20. Why? Because angle in the same segment are equal. This segment projects this 20. This segment also projects this 20. So they are both what? 20, 20. So we now consider this giant triangle. Let me write it out here. Like this, like this, like this. So this angle is given to be 28. The whole of this angle is 90 plus 20, which is 110. And the whole of this angle is here. which is x plus 20. So now, use sum of angle in a triangle. This x plus 20 plus 110 plus 28 must give us what? 180 degree. And that's what we did here. Now, in this diagram, TS is a tangent to this circle. So we are told to look for angle RST. RST, this angle here, let's call it X. They recall the last theorem given. From the last theorem given, angle in alternate segments are equal. So this angle here and this angle here in alternate segment. Check last theorem. So if this angle here is X, this angle is also what? X. Now when we check, RQPS is a cyclic quadrilateral. Sum of opposite interior angle of a cyclic quad is supplementary. So this angle plus this must be 180, right? So to get this angle, remove 117 from 180, and that is what? 63. Now, if you observe, these two stripes shows that RP and PS, they are equal. So definitely triangle RPS is an isosceles triangle. So if this angle here is 63, definitely this angle here is also what? So applying some angle in a triangle, we can get the value of x by adding 63 plus x plus what? And everything must be what? What is the answer to this addition? 126 equals to, so what value of x directly? In this question, we are told that AB is a chord of a circle. So let's say this is AB, chord of a circle. This is A and this is B. Tangents at A and B meet at T. So let's draw two tangents. One comes this way, other one comes this way, and they meet at where? At T. Yeah, like this. C is a point on the minor arc. This is the minor arc. C is a point on the minor arc. Let us see. And angle ATB is 54. ATB is 64. This angle here is what? 54 degrees. And CBT is 23. To show the angle CBT, we have to join this to this. So CBT, this angle here, is given to be 23 degrees. So the question is, find CAT, cat. CAT. So meaning you have to join this to this. CAT. This is the angle you are looking for. Let's call it X. CAT. Let's redraw a diagram. Abracadabra. Back to this diagram. Now let's consider this tangent AT. This is the point of contact. From this point of contact, we have this chord. So definitely this angle is the angle in this segment. Then this point, let's trace it here. This point, let's trace it here. This is the angle in alternate segment, and these two angles must be equal. Angles in alternate segment must be equal. This angle here is X. This angle too must be X because they are in alternate segment. So next, when two tangents meet externally, they project same length from the point of contact. So meaning AT and BT, they are equal. So the whole of angle A, the whole of angle B, and the whole of angle T must give us 180. Angle A plus angle B plus angle T must give us what? 180. So angle A and B must be equal because this triangle ATB is isosceles because AT and BT are equal. So we can say angle A and B, since they are equal, I can call this angle A, angle B also. Angle B plus angle B plus angle T must give us what? So from here we can say 2 angle B plus angle T equals to what? 180 degrees. So we can say 2 angle B. Angle T is 54 from here. Plus 54 equals to 180. If you solve this out, you are going to get B to be equals to. So if you divide both sides by 2 from here, it means angle B equals to what? 63 degrees. Let's now come back here. This angle B comprises of two angles, this x and 23. So definitely x plus 23 is the whole of angle B, and angle B is what? 63. So our x is 63 minus 23. So therefore x equals to 40 degrees. Ló bá ṣe kí ni o? Ló bá tán.